Hello everyone. Today I'm gonna give a presentation of how OpenSilver is able to translate XAML into HTML. I'm going to tackle different topics. So one is from a developer perspective, from a hello world. We're gonna look into inspecting the XAML tree in the simulator and also the HTML tree in the browser to get some understanding of what we're talking about. And then we're gonna have a look at the generated code from XAML to C#. And from there, we're gonna have a look at how the OpenSilver compiler does those changes to the code and how the runtime will render XAML to HTML during the execution of the app. And then we're gonna have a look at where those components are located in the NuGet package. And then we're gonna dive into the OpenSilver source code, which is on GitHub. A very quick overview of the compiler part, the runtime. And as a last step, we're gonna run an app and see from start to end what happens when you start the app and how the HTML DOM gets rendered from there. All right, so let's jump into the topic by creating a hello world. I'm gonna launch Visual Studio 2019, or you can use 2022. I'm gonna search for OpenSilver, run OpenSilver application, use the default name, choose the version of .NET, 5 or 6. I'm gonna use 5. So as you know, this is gonna create a hello world with just a simple text. So it's creating 3 projects here. One is the one where you put your XAML and C# code, or if you're migrating from Silverlight, you put your Silverlight code, and of course you can add some class libraries. And then there are 2 projects which are the entry points. The first one allows to run in the browser. The second one allows to run in what we call the simulator, which executes your .NET code in a .NET framework context so that you can have the full debugging experience of .NET. And when you want to deploy, of course, you will deploy via the .browser project, which is a project of type Blazor, client-side WebAssembly. And we're using Blazor only as the entry point because it's packaging the mono C# and .NET to a WebAssembly compiler. It's doing a great job at packaging it and keeping it up to date with the latest .NET versions. So we're going to focus on the main project here, which is where you put your files. And this project is of type .NET Standard, which means that you can also share it with other platforms. And let's make a very quick change. For example, I'm going to add a button and have some text here and create a button handler. And then in the code behind, I'm going to make some change to the text block text, for example, adding it works and the current date so that if I click multiple times, I can see that it's actually changing. All right, so let me start this. So first of all, I need to set the browser project up as the startup project. Let's run. Now it's compiling. Okay, Chrome has opened up. It's creating a local server. And here we go with the button which changes the text here. So I'm going to inspect this in a moment. I also wanted to show the simulator real quick, which is going to be useful to inspect the XAML rather than inspecting the HTML. So let me start this one as a separate instance. So as I said, the simulator is running the app in .NET Framework context, but it's rendering it in HTML via Chromium-based embedded browser here, which you can see. And from here, you can use the inspect visual tree to have a look at the produced XAML. And you can see there is the main page, inside of it, a canvas, the text block, a button. Inside the button is made via a control template, which has a grid, a content presenter, a text block, and the text block has a run. And I can change the values here if I wish, and it will update. So 1, 2, 3, then click OK, and it's updated. All right, so that was for inspecting the XAML. And the simulator, of course, lets you debug with the power of the .NET framework. Let's go back to the browser. Now let's open the developer tools and inspect this. So what you can see here is that each XAML element produces some divs. And in some cases, one XAML element produces multiple divs if you have some padding or for other layout reasons. And all the layout is done via CSS right now, which means that if I change, for example, the text of the button here, and instead of click me, let me write something longer here. You will see that the button grows and all the style is modified as well, because all the resizing is and layout calculations are done via CSS, and no C#, no JavaScript is executed to re-render the DOM. All right, so let's see how this code is produced. And by the way, while we are here, I'd like to point out the fact that there is an ID for each DOM element, and this ID will be useful to keep track of the DOM element from the C# context. All right, so first of all, I'd like to show you the code that is generated from XAML. So the first step when you compile an OpenSilver application is to get rid of XAML and replace it with the equivalent C# code. So everything that you can do in XAML, you can also do in C#. So let's have a look at the produced code. Let me build again this project, and then let me show the hidden files here. Go to the object folder, debug, net standard, and then you can see there is one file for each XAML file. So main page, let's open main page and put it side by side to the XAML. So you'll notice that main page has the initialize component method, which in Silverlight and WPF has some kind of magic to merge the XAML definition with the C# instance in memory. But in our case, we're going to get rid of XAML and replace it with some C# code, the page with the content specified in XAML. So again, let me build this. Okay, so now that it's built, we can see the content here. So basically, this is exactly what you would have done programmatically to get the same result. So you can see, for example, here we're creating a new canvas. We created a text block. We're setting the text of the text block. We're setting the attached dependency properties here, and adding the children to a collection, registering doing the events as we would do manually, and finally setting the content here. And because this element here, text block, has x name equals text block 1, we have generated here a field for text block 1, which is here, so that the C# code behind can deal with this element here. So this is the internal field that allows to deal with it, and it's populated at the very end of the initialize component method with a reference to the element that we created just above. All right, so this is the generation of the code, and we no longer have an XAML involved actually. Then when you run the app, this code is going to be executed. And when you arrive here, those classes are going to be instantiated. And then at runtime, those classes will render themselves into HTML. So to summarize, there are two main topics here. One is the compiler component, which creates this file. And the other one is the runtime component, where those classes are defined, which renders the DOM elements at runtime. So let's have a look at those two components real quick. So first of all, how those components are referenced. So for the runtime part, if I click go to definition here on the text block, for example, I can see the path, and I can see that it's in OpenSilver.dll, which is inside the NuGet package. What about the compiler? So first of all, let's have a very quick look at how this project is made in the CSproj. So you can see here the CSproj where the files are included, and it's just a package reference to OpenSilver package. So then we want to have a look at the OpenSilver package, which is on my C drive, users, NuGet packages. So we're going to have a look at the NuGet package, which is on C users NuGet, and then OpenSilver real quick, version 1. So basically, when you are referencing this package from a .NET Standard project, you automatically are referencing the libraries which are here. So we're going to reference the runtime, which contains the text block and everything else. And you're also automatically going to reference the target files, which define what should happen when you compile the project. So this file is very big. A lot of things happen here. So the one that is interesting for us is the XAML preprocessor, which, as you can see here, is imported from opensilver.compiler.dll, and then is defined here, basically getting the XAML file as a source and producing the C# code. So this is where the compilation happens. Now, let's dive into the source code of those two assemblies. So I've highlighted the OpenSilver.dll assembly here, and the other one is the compiler, which is in under tools, OpenSilver.compiler.dll. So where is this source code located? It's obviously on GitHub /OpenSilver again. So just real quick, this repository contains the source code of both OpenSilver and CSHTML5, which is the sister product which shares most of the same files, but compiles to JavaScript instead of WebAssembly. So there are two main branches, develop and master, and you should use develop for the latest versions, and master corresponds to the packages that are on NuGet.org. So be sure to read this page here to know exactly how to build the code. Let me open it real quick. So here I've cloned it locally. As you can see, as I said, there are two solutions here. Let's open the OpenSilver one. So this solution is very big as it contains all the components, but we're gonna focus only on two. So let me collapse all here. So the compiler first, this is the assembly that I've shown to you. There are different steps. You can see 1, 2, 3, up to 6. And the step I'd like to show is the converting XAML to C#, which is here. And the entry points are in this folder. So those classes are the ones that are referenced from the target file that I've shown a moment ago. So I've shown to you the XAML preprocessor target. And it's actually exposed because it's a public class which inherits from task, which comes from Microsoft.build.utilities.task. So the target file is gonna execute the public override Boolean execute method, and from there it generates the file. The interesting bit of code is here in the generating C# code, and there are two passes. And the reason why there are two passes real quick is if the user project contains a user control and you want to reference that user control from XAML, which is defined in the same project, and then you set some properties on that user control in the XAML. The XAML preprocessor needs to do some reflection from that user control to know exactly what the type of those properties are and so on. So there's a first pass which basically compiles without the XAML so that the user control gets compiled, and then the second pass which converts the XAML to a C# while doing the C# reflection on the user control. All right, and then this is obviously a tree traversal where all the elements are converted to C#. So that's the compiler component. Now let's talk about the runtime component, which is the most interesting one today. So the runtime is located here under the runtime folder, and it contains, so it's runtime.opensilver, and it contains all the controls under, for example, system.windows.controls. You're gonna find the button, the text block, and everything else. So before diving into the internals here, I'd like just to give you a general idea of how this thing works. So most of the controls in the runtime are built on top of other controls. So for example, the button is built on top of button base, which is a C# class, a pure C# class. And so a button base contains the click event and so on. And then a style is defined. If you look at the style, you can find all the default styles under the default styles folder of runtime.opensilver. If you look at the style, then the button, you can see that is made of a content presenter, a border, a grid, and basically other XAML controls. So in that case, there's nothing to show here. This is a standard C# XAML, very similar to that of Silverlight and WPF. And so there's no HTML here at all, actually. Now, the low-level controls are the ones where you will find some HTML mapping, and those are the text block, because at some point you will need to render some text, and other low-level controls, which some of which we're going to see in a minute. So all those low-level controls, they have a specific method that is specific to OpenSilver that basically allows it to tell how they should be rendered in HTML. So let's see some examples here. Let me start by some simple stuff. So the web view control, which is actually called web browser in Silverlight on WPF and web view in UWP or WinUI, and we support both actually thanks to this compare directive. So this control is used in Silverlight to display a web browser inside the Silverlight app. And in our case, because the OpenSilver app is running in the browser, we just want to display an iframe actually. and set the URL of that iframe. So this control is actually very simple in OpenSilver, whereas it's more complicated on other platforms. So that's the method I've been talking about. It's create DOM element, and this method is specific to OpenSilver. You won't find it in Silverlight or other platforms. It's an override that comes from a parent class, and in this method you get a reference to the parent div, the parent DOM element, and it should return the div that's created. And in this method, it's going to create the DOM elements. So you see, for example, that to create this web view or web browser control, we're going to first create a div. You can see here. We're going to put it inside the parent ref. And this is going to return a reference to the created div here, which we're going to call outer div. And it's also going to return a reference to the div style, which is basically outer div.style, which allows to set some CSS properties on it. And then inside this outer div, we're going to create an iframe element, which you can see here, which we're going to call underscore iframe. And this is actually stored as a class variable because it's going to be helpful later when we change some properties in XAML or in C#. We want to reflect them in CSS. So how does setting the source URL work? So in C#, there is a source URL, a source URI, which defines the page we want to show inside the web browser, inside the Silverlight app. We're going to set the src property of the iframe DOM element, which is $0. So it's the standard interop syntax, which is documented on the OpenSilver website. We're basically going to say that $0 is the iframe because it's the first argument, $1 is the second argument, and so on. We're going to set the src property equal to the URI, which is here. Now this create DOM method is called when the element is attached to the DOM tree initially when it's first rendered, and I will show exactly the timing in a moment when we do the full path of execution from start to end. But then when the UI element is already on screen, you may want to change its content and change one of its properties. So let's say we change the URI property once the element is on screen. So that's where we look at the source URI property, which is a dependency property. And so as a dependency property, it has a source changed event handler. And if we look at the definition of the event handler, we can see that, first of all, we're going to check whether the element has been loaded, which means that the DOM element is present in the DOM tree. And then if the URI, if the property is valid, we're gonna set again the src property to the new URI. So that's the.
Is this property is loaded? Is this specific to this control, or there is similar properties to all the controls that are created by?
Which property, src or
is
source?
Loaded on
is loaded. Okay, yeah, sure. So the is loaded property, we have one on the UI element, and it can be used everywhere. So this one here comes from UI element, and all the controls have it. Now, rather than using this one, you will probably want to use the public one, which is with an uppercase and without the underscore. Let's see another example. Yeah, let's have a look at the media element control as a second example. So the media element allows to display a video or to play an audio file. And again, it's a very low-level component, so it has a create DOM element method here, which basically is going to create a div, so just a simple div. And then let's see what happens when you load the video file. So let me find the part where the video file is loaded. So basically, you're going to set the source of the video file, and when the source is changed, we're going to check that the control is in the visual tree. So you can also use this method isElement in visual tree, or you can use control.isLoaded. And then we're going to create a DOM element at this point. We're going to set a specific tag. So instead of a div, it's going to be a video, for example, or an audio. So depending on the file type. So that's why we do not create it in advance. Actually, we create the div, the DOM element only when we set the source. So it can be either a video or an audio tag. And the element is created at this point. We set the size, and then we set the src property. And when you play the video, we're going to call the DOM method play on the element, on the video element here. So there are a bunch of helper methods to call these things, but you can also do those calls manually by calling interrupt.execute JavaScript and then media element.play, and you will get the same result. All right, so that was a very quick overview of how each control defines how it should be rendered in HTML. To complete this presentation, I'd like to guide you through the whole execution of Hello World. So what happens when you start the app up to the point where the DOM elements are rendered on screen. And then I will take your questions. So let's go back to the demo project here, so the Hello World project. First of all, what happens when you start the browser project, which is the main one to run in the browser. So this is, as I said, this project is of type Blazor, client-side, WebAssembly project. So it's very similar to what you would get if you create a new Blazor client-side project from the project templates of Blazor. And so when you run it, it's going to run the program.cs class and the run application method here. So this is where we arrive into OpenSilver. So this code is going to call the constructor of the app class in your project. So let's go to OpenSilver application 8 project. And basically we're done with the Blazor stuff. Now we are all in OpenSilver.NET standard code. So we're now creating an instance of this app class here. Now this app class, which is very similar to the one you get when you create a new Silverlight project or WPF project or even UWP as well, inherits from application. So application is defined in the OpenSilver runtime. And so when we create a new instance of app class, it's going to create a new instance of application. So the very first line of code that is going to be executed is actually in application.cs in the OpenSilver runtime. So let's go there. Let me search for application.cs in the runtime. You can see that it's in two parts, as most of our classes are. This one contains the methods that are implemented and that have been tested, and the other one contains work in progress methods. Most often there are stubs or empty methods just to get some application code to compile, and the empty methods have an attribute that says it's work in progress, so that when you compile an application that uses those, so the application does compile so that you can move on to start running it and debugging it, but you get a compiler warning that says this method is not implemented. All right, so let's go to application.cs and let's go to the constructor. And here we are. This is the very first line of code that is executed, which basically is going to store what is the current application, so that then you can call application.current.something to change some settings like you would do in Silverlight and so on. All right, so let me directly jump to the interesting things here. So we have this concept of window. Silverlight is a single window platform, right? But for example, WPF has the possibility to have multiple windows. So basically the window is going to be the root of our application, and it's going to be associated to a DOM element. And then everything you put inside the window is going to be appended to that DOM element. Now in OpenSilver, we do have the possibility to create new windows. So you're going to just instantiate new instances of the window class. And the goal is, for example, to have other root elements in the DOM. And this is particularly useful if you wish to integrate the OpenSilver application inside another kind of application like Angular, React, or somewhere else, and you would like to have two roots of the app. So for example, you would like to have an OpenSilver control in the bottom left of the Angular window and another OpenSilver control in the top right corner. So you're going to create two different roots, and between the two is just going to be Angular. All right, so this means that first of all, the application is going to create a new window. So let's scroll down to that part. Here it is. It's creating a new window. It's setting it as the window.current, and then you can access the root of the application from there. Two things here. So one is the attached DOM element method. So as I said, the window is going to be attached or linked in some way to a root DOM element. So this root DOM element is the one that you can see in index.html. So let's go back to the application code here. And if I expand the browser project, I said there's not much interesting for us in this project except the entry point. But actually, there's also www root where index.html is defined. And by the way, here's the loading indicator. So the animation when the application is loading, it's actually done in CSS because the .NET runtimes has not been loaded yet. And if you wish to customize the splash screen, the loading indicator, that's the place where you want to do the change. And index.html is very simple and short, as you can see here. This is the place where you may want to add some JavaScript libraries if you wish to later use them from C# code, or alternatively, you can load them in C# via our API, which is documented on the OpenSilver website. So you can see here there is a div that is named OpenSilver root. You can create other roots or put it elsewhere or define this div dynamically in JavaScript if you're using Angular, React, or something. But basically, our main window is going to look for a div which has this name. And let's go back to the OpenSilver runtime. And that's where the linking is going to happen. So how does it work? First of all, we get a reference to the div via the get application root DOM element. So this is just a bunch of interops which look for OpenSilver root element you can see on screen. And then this is an object because it's a JavaScript object. It's a DOM element. So C# doesn't know anything about the types of the DOM elements. So it's going to be manipulated as an object, and internally is going to be a reference to the DOM element. And so we're going to pass this object to the attached DOM element method on the window. And so then XAML knows that when this window needs to be rendered, it should render itself inside that DOM element. So this is one of the two things I wanted to say about this. The second thing I wanted to say is that the window class, like in Silverlight, has a root property. So it has a content property. Sorry. So now let's go back to the Hello World application and let's see how the visual tree first is constructed. So how the XAML elements are nested. So when the application is launched, you can see in the constructor, we create a new main page and we set the content of the window to be that main page. So basically, you can imagine the visual tree is going to be window, then window.content contains main page, and main page.content contains the stuff that we saw, the button and the text block and everything else. Now let's see the timing of the HTML creation and so on. So we saw that first of all, application.cs is instantiated. Then we arrive to this constructor here. Initialize component of app is just going to load some styles if you have put any styles in app.xaml and so on. Then the main page is instantiated and set into the content of the window. So until now, there is no DOM created yet. Now, the very moment you set content of window to be main page, HTML is going to start being rendered. So let's see why and how this happens. So let's go to the content property of the window. So let's go to the content property of the window. So I'm going to click go to definition here to know where this thing is defined. So it's under window. So I'm supposed to see it somewhere here. Here it is. So content is a dependency property. Again, it has a content changed event handler where the content changes. And when the content changes, we have an old value and new value. Old value is going to be null. New value is going to be the main page. So we arrive on content changed. First of all, we do something only if the window itself is loaded. And again, in this context, being loaded means that a DOM element is associated to it. So is a DOM element associated to this C# instance? Well, yes, because in application.cs, we have called the attached DOM element method, which means that yes, a DOM element exists, is in the tree, and so we can proceed. Now, the DOM element is there. So first thing is we want to detach any children if there is any, but in our case, the window was empty. And then we're going to attach the children. So attach and detach in this context doesn't mean that we attach and detach to the visual tree. It means that we attach and detach to the DOM. So for this, we're going to call the visual tree manager helper and just say, please attach this other XAML element, which in our case is going to be the main page. And so here begins a recursion where for all the elements, they're going to attach their own children. And every time that they attach their children, the create DOM element method that I have shown earlier is going to be called, and the DOM elements will be placed in the tree, and so on. This will be the last thing I will show in a moment. But before showing this, let me state this clearly. Every time that you change the content of a control, I'm talking about the low-level controls, the panels, for example, and other low-level controls, they are going to check whether themselves they have a DOM element created. And if they do, they're going to detach and attach the new elements. And when they do that, the create DOM element method is going to be called, and the corresponding DOM elements are going to be created. So for example, if I have a border and I change the child property of a border, So the child property is not a dependency property actually. And in the setter of the child property, we're gonna detach the previous content from the HTML DOM and attach the new content. And so to finish my presentation, let's see what happens when you call a method to attach in HTML. So basically, I'm gonna go to the definition here, and again, go to the definition here. So here you can see a very quick explanation in the comments of what the structure is going to be. Basically, we're going to create several div elements for each XAML element. There's going to be a wrapper. If it's a panel, there are going to be some inner divs and other, there's going to be a wrapper for each children. For example, if it's a panel, if it's a grid, we're going to use the CSS grid layout for best performance. And so each time that we append a child to the grid, we're going to create a specific div around that child that will be used to specify where in the grid it should be located, which column, which row, and so on. Let me scroll down this method real quick. So as I said, if needed, we're going to create a child wrapper if it's a panel. So the low-level panels like a grid, they override this method, create DOM child wrapper, so that they can specify how the children should be wrapped. So that's the same for a stack panel, for example, depending on the orientation. If it's horizontal or vertical, it's going to render using different CSS properties, and it's going to have a wrapper for each children. So we're not going to look at all the steps, but the main thing here is where the create DOM element method is called, and here it is. So here we have two possibilities. Either there is a control template applied to it, or there is not. So let's just tick for the no control template. And again, if there is a control template, no HTML is involved. Actually, we're going to just create other XAML elements and so on. So this is only for the low-level elements. And this is the place where the create DOM element is called. And then it's going to be attached to the DOM. All right, so this concludes my presentation. And I'm now available for any questions. So I hope this has been helpful. You got an idea of how the HTML elements are created from XAML. And if you have any questions, I will be very happy to answer.
Thank you very much. I have a small question. You have demonstrated main page.g.cs and you have to show hidden items. I don't understand how we include these items into the solution because they're definitely not included.
Sure. So let me detail this real quick. All right, so let me build the project so that those files are generated. Okay, so the question is, when we have the step that converts XAML into C#, we have seen that some hidden files are generated under the obj folder. So if I click show hidden files, I can see the main page, the xaml.g.cs here. And then during the compilation process, the XAML file is discarded, and this generated file is included instead of the XAML file. So how does this happen? So this happens inside the target file. The OpenSilver application project is a .NET Standard project which references the OpenSilver package. If we look inside the OpenSilver package, which is here, we can see that it has under build two target files. So this is going to be the entry point, and it's referencing this other file. And we have seen that inside this target file, there is a step which is called XAML preprocessor that generates the C# file. So what happens then is we have another step which is going to include that file into the project temporarily, just during the build process, and it's going to exclude the XAML file. So let's see precisely where this is located. So first of all the XAML files that we have generated are going to have the g.cs extension, and they're going to be listed inside this temporary variable, which is called processed files. And the key is these lines here. So this is going to remove from the CS proj in some way. So the tree that MSBuild generates from the CS proj is going to remove all the files that have the XAML extension. So basically this is going to tell remove all the elements that have the content tag and that satisfy this condition, which is basically their extension XAML, and include all the files that we have listed here before and include them using the compile tag. So here I could have put the content tag or something else. It doesn't matter. So in this particular case, these files are going to be included with compile. So this is going to produce the exact same result as if in the CS proj you had written the compile tag with include and then the path to the file.
If there are no questions from my mates, I would have one. So let's assume that one application, Silverlight application, uses a button, just a simple button, but the button has a kind of a gradient color. And after I migrate that one to OpenSilver, it's not just looks like with a gradient color out of the box. And I have to update OpenSilver, I guess. So where we are doing that? So let's.
Sure. So that's a very interesting question. If you notice that the OpenSilver application doesn't behave exactly like Silverlight would, what do you do and how do you dive into this topic? So the very first instinct should be to isolate the bug in a separate project. So you would create a hello world as we have done now and make sure that you really isolate the bug. And to do that, you may need to do some dichotomy, like splitting and removing and commenting out some code. If you comment too much and the bug disappears, then you reintroduce some code and you can do this kind of things. Or you can start from scratch and add some code to the hello world until you get to reproduce the bug. And then you can start removing things until you really get to the very minimal reproduction code. Next, you should really master the way you can debug the OpenSilver runtime, which means being able to have a functional step-by-step debugging. And this usually involves cloning the OpenSilver source code from GitHub, compiling locally, building the package locally, making sure that you have the PDB files which allow to have the breakpoints being hit, and so making sure that your environment is set up in a way that you can do step-by-step debugging on the OpenSilver code. You can do debugging in the browser, of course, and you have the same kind of debugging capabilities as debugging C# code in a Blazor client-side WebAssembly project, which means that it's getting better and better with all the .NET releases. But you can also use the simulators, as we have seen, which allows to debug in C# using the .NET framework debugging capabilities. And so I really recommend you to do that and make sure that you are able to debug the OpenSilver runtime. Now, you mentioned the specific example of a gradient not being rendered properly. Let's discuss very quickly how gradients are rendered. So what you would do is, as I said, in the hello world, you would put a gradient, then you do step-by-step debugging, and at some point, you will very likely enter the linear gradient brush class, which I'm going to show here, because you will very likely be using this class to create the gradient. And so what you could do is just put a breakpoint in one of the methods that you're setting. To put a breakpoint, you run your minimal example, you hit the breakpoint, and then you look at the call stack to know where you are in the code execution and what has happened before that. So most likely, if you put a breakpoint here, you are in one of the generated C# classes from XAML, like mainpage.g.cs in the initialize component. So you're basically constructing the visual tree at this point. So this is the first step. So the first step is making sure that in memory, in the visual tree, you have everything that is correct. So the values are there, and especially if the application is using some Silverlight APIs which we have not implemented, you may see in the code here some unimplemented attributes, and maybe that's a place where you should look at. So you can inspect the visual tree from the simulator, but also by step-by-step debugging. If you continue until you get to the end of the initialize component method, you can then hover the different variables and content of the main page and inspect the visual tree like this to see whether all the values are correct. Now, the second thing is when the HTML is created and it is updated. So if I'm setting a gradient brush, I've shown earlier that like the properties in the media element or in the web view control, the properties are set at two moments in time. So one is when one of the parents starts to be in the DOM tree, then there's a recursion that happens that is going to attach to DOM all the children. And so the HTML will be rendered once at that point of time. And then there is a second time, which is if later, while the HTML is there, while the application is running, if later in C# you then change that property, you change one property. And so we then enter the changed event handler of that property, and the HTML is again updated at that point in time. So for debugging, you have those two approaches, and maybe the second approach is easier because it's easier to isolate, and you are not confused by all the other XAML elements that are attached. So what you you could do then is you could create a button in your Hello World that sets the linear gradient brush so that you know that when you click that button, this is the only thing that is going to happen is setting this linear gradient brush. And it's probably easier than to do step-by-step debugging on that. And most likely when you do so, you will notice that we'll be entering the foreground property or background property of a UI element. We'll be entering the setter of that property, or you will be entering some property of the linear gradient brush. And then from there, you can have a look at the interops that take place to update the HTML DOM, to update the CSS properties. And most likely there is an error, there is a mistake that was done in that implementation. And maybe some XAML values are not mapped properly to the corresponding CSS. And that's where you may want to change something. So let me give you some very quick example. In the text block class, we have some text properties like line height. And so line height, let's say you set line height, and for some reason when you run the app, it's not the exact same line height as you get in XAML. So that's probably where you want to look at. This is a low-level property, meaning that it's not pure C#. There is some OpenSilver specific things to map to some corresponding CSS. And where does this mapping occur? It occurs here. So you can see it's a standard dependency property. But then when we pass the property metadata, which allows to set the initial value of the dependency property, and this is all standard things, we have a non-standard API, which is the possibility to specify a method to update DOM. So that's the name of the properties, method to update DOM. And here is the place where you do the mapping between the C# value of the dependency property and the CSS. So what happens is that when this property is changed, and again, it could happen 2 times, either when the first time the control is rendered together with the whole XAML visual tree, and when you change this specific property later at runtime. So in both cases, this method is going to be called. And then we can see in this specific example that we're going to call a helper method to set the CSS. So I'm going to dive into this. So basically, we're going to take the C# value, convert it to string, add the px to the end, and then call this helper method, which is basically going to, first of all, check whether the DOM element is really there. Otherwise, we would be changing the style of a DOM element, which is not in the DOM tree. And then it's going to call another helper method to set the style. This could actually be simplified. It could be done manually with an interop. So again, interop.execute JavaScript, you pass the reference to the DOM element, and then you pass it as $0, and then you put dot line height equals value.px. But we have some helper methods because this is done everywhere in the OpenSilver runtime, and so we have those helper methods there. But the concept is exactly the one that I said, just calling an interop, which is going to be executed in the JavaScript context, and it's going to set via JavaScript the style of the DOM element. Does this answer your question?
I have one question. When I study this framework, so like if any situation arises during the migration, how we are dealing with that? Like we need to explicitly call helper functions, or we are planning to give a common solution like that for that kind of situation?
So we are talking about a situation where you have some controls that are overflowing over other controls.
Yes.
And they shouldn't. And so how to deal with that?
I mean, like for that, we need to manually, like as you mentioned in the session, right, that we can use the helper method. Like we can pass the CSS as well to HTML side from OpenSilver framework. So that is only way, or we need to think on the common approach as well, like component change or that.
Yes, you would need to make a component change. I mean, you could create a workaround on the end user application, right? Put some CSS with interops or do another change like this. However, if you notice something that is rendered differently in OpenSilver compared to Silverlight, you really want to fix it in the OpenSilver runtime instead, so that it then gets fixed everywhere throughout the app. So all the places that have this problem in the app are also going to be fixed. So rather than creating a workaround via the methods that you were referring to call CSS and so on, it's better to spend some time to get an understanding of how the OpenSilver runtime works, how the controls are rendered, and pinpoint the exact cause of the issue. For that, it's absolutely mandatory to isolate the bug to the smallest possible reproducible example, because otherwise you will be lost in all the layout calculations that are happening and all the interrupt calls that are there. So you really need to pinpoint a specific place in the OpenSilver runtime that is not functioning properly. From there, you can play with the OpenSilver runtime to change the controls, the very low level parts of the controls, and compile again, run your isolated example again, see if it's fixed there, and then run the full app to see if it's also fixed in the full app. From there, we go to a process of testing. So we test the showcase, which is publicly available on GitHub, to see whether it causes regressions in the showcase. We also have a test application project, which is in the same repository as OpenSilver. It's a test application. And what's nice with this test application is that it has a Silverlight version and an OpenSilver version that share the same code. So the minimum reproducible example, once you have it fixed, you should put it into that test application, which allows us in the future to cover that as well and prevent regression from someone else coming into the code and saying, why did this person make this change, and then reverting it, and then it breaks again what you changed. So you really need to add this test case to the test application. And with this test application, you can constantly compare the Silverlight version and the OpenSilver version. From there, we also test all the other applications that we have migrated so far, those that we are migrating. And usually for this kind of issues, you would probably be changing some very low-level system of layout, which means that most likely if it breaks something, we will see it somewhere. So rest assured that it's very likely that we'll see it. So you can go ahead and try and break things and re-engineer OpenSilver runtime. And please, you are very encouraged to do that. You shouldn't think like, whoa, I don't want to break other things. It's okay if you break things. You will just make a pull request. And it's going to be tested, and it will only be merged if it's safe. But on your side, you are encouraged to break your code. Especially the general workflow would be that you create a fork of the OpenSilver runtime. Then on your fork, you're encouraged to break everything and make all the changes possible to fix the issues at the OpenSilver level. And then when you think you have found a solution, please test the showcase at least and the test application. So you have 2 tests to do. And these kind of things are also documented in the contributing page on the GitHub repository. And then if you don't see regression on those, please clean up your code, make sure that it's the same APIs as Silverlight, and you're not using an API which doesn't exist in Silverlight. I'm talking about public methods and the overloads and so on. If you have some overloads that are not completely implemented, please put the attribute work in progress or not implemented. You can have a look at the work in progress folders in the OpenSilver runtime source code to see what's the best practice there. And then clean up the namespaces, make sure it's a Silverlight one, but also if you can, please also create the namespace for the UWP version. As you have seen, each class has the 2 namespaces because it's easy for us to maintain also UWP version, at least for the namespaces, and it's useful to many people. And then if you have a chance, please also make sure that CS_HTML5 also compiles. So right now, the CS_HTML5 code and the OpenSilver code are shared into the same repository. There are 2 different solutions. CS_HTML5, that's SLN, and OpenSilver, that's SLN, with the instructions on GitHub on how to compile both. So please make sure that when you make a change on OpenSilver, CS_HTML5 will also compile. And then you're done. You can make a pull request to the develop branch on the main OpenSilver repository, and we will look into it, making sure that there are no issues. Otherwise, we will just communicate with you to work with you to fix them, and then they're going to be merged. So does this answer your question?
Yes. Actually, yesterday I was looking for the requirement of the client. So at the time, there is a case where they are dynamically shifting the components like a designer. So it may be possible that a constant DOM change might be there, shifting the components and generating the form. So that's the reason I asked this question. Like if we modify the DOM, right, and certain level, like in a browser, it will give some sort of behavior. Then how we need to resolve that kind of stuff? Like is that in our plan or something? That's the reason I asked that.
So that's where you are invited to help us to fix this. So the ambition to get 100% of support for Silverlight is very big, and we need the help from everyone to make this possible. So if you encounter an issue where the layout doesn't render as expected, you shouldn't wait for someone else to fix it, but you should, as I said again, but it's very important, isolate it in a very small project, and then dive into the OpenSilver runtime to fix it there, and so that everyone will then benefit from this fix. And in the test project that I mentioned earlier, there is a section related to a very atomic and isolated layout experiments. Like, for example, you have all the possible margins and negative margins. You can already play with the client application in the simulator, inspecting the XAML, playing with the properties. You can change the properties in the simulator to see exactly where the problem comes from, and splitting the application into small pieces, removing stuff from the application to see at which point the problem is no longer there, which can help you to determine that it's due to negative margins. And then once you have found that, you should sort of reproduce it in a separate project, then make sure your environment is set up so that step-by-step debugging works great on the OpenSilver runtime when running in the simulator, and then do step-by-step debugging to understand exactly what happens when you set a negative margin and what CSS properties are used for that. And most likely you will find the cause of the issue. You can fix it there by changing the OpenSilver runtime in your fork, then test, showcase, and test applications, make sure there are no regressions, then make the pull request on the develop branch of the main OpenSilver repository.
Thank you.
Thank you. Any other questions?
If we don't have any more questions, that was pretty long sessions. It was very interesting. So maybe we can leave it there. Let me turn off the recording and then I'll have a few words before we go.
Great. Thank you very much, everyone. Thanks a lot.